Hey everyone! So, if you've been building with large language models, you know that amazing feeling when you craft the perfect prompt and get a brilliant response back. But you've probably also felt that sinking feeling when that same model just completely falls apart on a real-world problem. Well, today, we're going to level up. We're moving beyond just talking to models to designing their entire world. Let's get into it. And this is the question, right? It's the one that keeps so many of us up at night. You've got this incredibly powerful engine. It can reason, it can write code, it can summarize better than anything we've ever seen. But the moment you try to connect it to your company's private documents or ask it about something that happened yesterday, the cracks start to show. The thing is, it's not about the model's intelligence. It's about what the model can see. So here's how we're going to break this all down. We'll start with the basics, the power of prompts. Then we'll look at why that's not always enough. After that, we'll dive into the big idea, context engineering. We'll unpack the tools you'll need. And finally, we'll map out that journey from being a prompter to becoming an architect. Okay, let's kick things off with section 1, the power of prompts. This is level 1. This is the starting line for pretty much everyone working with these models. You know, prompt engineering is really our first essential skill. It's all about the art and science of crafting your input to guide the model exactly where you want it to go. I mean, the way you phrase a question can totally change the output, from useless to amazing. It's the absolute foundation that everything else is built on.
And this really breaks down our basic playbook, right? You've got zero shot where you just ask for something directly, like translate this sentence. Super simple. Then there's one shot, where you give it a single example to show it the format you're looking for. But where things get really powerful is few-shot prompting. Here, you're giving it a handful of examples so it can actually learn the pattern you want. This is how we start to teach the model right inside the prompt itself.
Okay, moving on to section 2, when prompts aren't enough. Because this is the moment we all experience. It's where we hit the wall, when you realize that even the most perfectly crafted prompt in the world has its limits. This quote just nails it. It gets right to the heart of the problem. You're building a real application, and bam, the model knows nothing about your company's data, nothing about yesterday's news, and it has no memory of what you just talked about 5 minutes ago. And even worse, it'll just hallucinate. It'll make up an answer with total confidence. And that right there, that isn't a failure of your prompt, it's an architectural problem. And this is the root cause. It's called the context window. The best way to think about this is as the model's short-term memory. It's like a whiteboard or the RAM in your computer. It's the finite, and I mean finite space, where it holds all the information for the task at hand. Every single word, every instruction, it all takes up space. And when that whiteboard is full, older stuff just gets wiped away to make room. So you're probably thinking, okay, simple. I'll just get a bigger whiteboard, right? Well, it turns out that just making the context window bigger creates a whole new set of nightmares. The model starts getting lost in all the noise. Suddenly you have context confusion where irrelevant info distracts it, or context distraction where it just repeats itself. You can even get context clash from contradictory facts, or worse, context poisoning, where one bad piece of information gets in and just snowballs. So yeah, just stuffing more data into the prompt is definitely not the answer. And this brings us to the solution, section 3. Enter context engineering. This is where we graduate. We go to level 2. We stop being just a prompter, and we become an architect. We stop trying to fix the model from the inside and instead start building a smarter system around it. So what is context engineering, really? Well, simply put, it's the discipline of designing the architecture that feeds an LLM the right information at the right time. It's not about little prompt tricks anymore. It's about building a robust system. It's about making sure that brilliant model has precisely what it needs to reason effectively. No more and no less. I absolutely love this way of looking at it. We're not trying to perform brain surgery on the LLM itself. We're the civil engineers. We are building the bridges that connect that isolated, brilliant brain to the real world, to your private data, to live APIs, to a memory that actually lasts. This is the whole paradigm shift. Okay, section 4, the architect's toolkit. So now that we get the why, let's open up the toolbox and look at the how. These are the core skills and components that you're going to need to master.
First up is retrieval. This is that first big bridge to all your external documents. The secret sauce here is a technique called chunking, breaking down huge documents into smaller, manageable pieces. And the whole game is finding what they call the chunking sweet spot. You need chunks that are precise enough to be found by a search, but also rich enough to give the LLM meaningful context to work with. Seriously, if you get this part wrong, the whole system just falls over.
Next up is query augmentation. Let's be honest, users are messy. They don't talk like search engines. This tool is basically a universal translator for them. So look at the example here. It takes this vague, frustrated question, how do I make this work when my API call keeps failing? And it transforms it into a set of precise machine searchable keywords. Things like API call failure, rate limiting, 500 error. Now that is something that can actually find the right document.
Now let's talk about the conductor of the whole orchestra, agents. An agent is the actual decision-making brain of your system. This is what's so cool. Instead of just following a fixed script, an agent can actually reason about a problem, figure out which tools it needs to solve it, use them, and remember what it's done. This is what unlocks truly dynamic, multi-step problem solving. Of course, to do any of that, an agent needs memory. And we really have to think in two layers here. You've got short-term memory, which lives inside that tiny little context window we talked about. That's for immediate, in-the-moment reasoning. But then you have long-term memory, which is stored externally, usually in something like a vector database. This gives the system a real sense of history, persistent facts, user preferences, past conversations, you name it.
And finally, tools. How does an agent actually do stuff in the world? This is it. Tools give the agent hands. And it works in this really powerful loop. First, the agent has a thought like, I need to know the current weather. Then it takes an action like calling a weather API. It gets back an observation, the data from the API. And then it reflects on that observation to have its next thought. This thought, action, observation cycle is the engine that drives any modern agent system. All right, let's move to our final section and pull this all together, from prompter to architect. This isn't just about learning a few new skills. It's a fundamental shift in how we think about our jobs as AI engineers. And this image just captures the entire journey perfectly. On one side, you have the old way, a simple prompt going into a model. On the other side, you have the new way, a full context engineering system. You have a user request coming in, but before the LLM ever sees it, the system retrieves knowledge, accesses tools, and consults its memory. We've gone from just talking to a model to building the entire world that it lives and reasons in. It's a huge leap.
So here's the bottom line. The big takeaway from all of this is that we're moving past the era of just chasing bigger and bigger models. The real breakthroughs, the truly magical AI systems, aren't going to come from bigger models. They're going to come from better engineering. From us, from the architects. So the real question is, what world will you build?